The first thing that I found most people have a challenge with is naming a molecular structure, right? Even though it might look simple for most people, but there are things or rules which you should follow. So before we do that, let's introduce a few things and our properties that we are going to use as we name, right? So the first thing that you should look at is our prefix. So I would say that when naming, the full name should consist of, yeah, it's better to do this. When naming, your full name should consist of a side chain name. Let me write there. Side chain name, your prefix and its position. I'll just put P there. Its position, your prefix. I'll just put P there, your position, and your suffix. I know this this is so unconventional, right? Because it's not something you're taught. I'm just trying to formulate a structure for you or a pattern that you should follow every time when you try and name something, right? So let's identify this prefix. So since this is a language that we use, right? Then if you have one carbon, then your prefix will be meth. If you have two carbons, your prefix will be earth. And one thing I should mention that a carbon can be bonded to 4 atoms only, right? So if it's more than 5, then there's something wrong with your structure. You have to double check that. Then if you have 3 carbons, then it's prop. We can go on right up until 8 or 9, but you get the pattern, right? So if you have 4, it's going to be but. That's for 4 carbons. If you have 5, it's pent. If we have 6, that's going to be hex. If we have 7, that's going to be hept. If you have 8, that's oct. So these are your prefix. Every time when trying to name a molecular structure, it should consist of a prefix, and these are your prefix. And how do you find a prefix? In your molecular structure, I'll show you rules to follow, right? The first thing that you'll do, you'll identify the longest chain, check for other things, but in place of prefix, we are going to use this. We have one thing that we call a hydrocarbon, right? So in the name, so hydro, it means that there are hydrogens and carbons. So the simplest way I'll define this is we have a carbon bonded to hydrogens. You can go and look for a proper definition, right? But this is basically what you're looking at. Not necessarily, or this is not the only case, right? You can have multiple carbons and different bonds between the carbons and all that. But the hydrocarbon consists of such things. So for the sake of understanding, I'll classify this as types of hydrocarbons. So the first one that we'll cover is alkane. The second one, it will be alkene. The third one, going to be alkyne. So let's start with the first one. Let me use a different color here, right? So under alkane, you have to identify one thing, right? The general formula. They always ask such questions. What's the general formula of alkene or of this molecule? So you have to check for other things. So the general formula here will be CnH2n plus 2. It doesn't change, guys, right? So how do we identify an alkene? So in between the bonds, of carbon with a single bond. You can see, right? So in between the C atoms, there is a single bond. In between the C atoms, there is a single bond. And what other thing? Yeah, that's how you identify one. Then the suffix now, you see from the name or the naming convention that you have prefix, then position, then suffix. So suffix for alkane, it will be ane, right? You get it from the name. I hope we're on the same page, right? One thing I should mention that an alkane is a saturated compound. Then you'd ask, what's a saturated compound? So a saturated compound, it's when there's a single bond between the C atoms, right? Or you can say the C, yeah, there are single bonds between, let me remove this, between the C atoms of a molecule, right? Then another one, it will be alkene. Then here, the general formula, is CnH2n. How do you identify it? Have a double bond in between the C. So you can see here we have a double bond, right, in between the C carbon. We can have cases where you have multiple double bonds in different positions, but that's something I doubt you'll ever encounter that. Okay? So here it's the double bond, double English, right? Oh my God, double bond between the C atoms, right? The suffix, here it's in the name, it's ane. Lastly, under our hydrocarbons, we have alkyne. The general formula of this one is CnH2n minus 2. And how do you identify that one? You can take a guess, right? We'll have a triple bond in between the C atoms. So you can see, right? A carbon can only be bonded to 4 atoms. Let's count. 1, 2, 3, 4. If I have to add something there, it will be wrong, because if we were to count the bonds that we have between this single atom of carbon, you'd find that it's 1, 2, 3, 4, 5, 6. So you have to be careful about that. You might get confused at some point, but it's fine. Hopefully, I'll try and clarify that as we do more questions and exercises. So this is how you identify one, right? So there is a triple bond between the C atoms. Then the suffix is in the name, Y and E. I said alkene and alkyne fall under one category, right? So there's what we call an unsaturated compound. So this one, I can call it a compound that consists of double or triple bonds between the C atoms of a molecule or an organic molecule or organic molecular structure. You just have to go and check for a proper definition, but in explanation, that's what we have. So here we have alkene and alkyne. Then let's try and do some naming, right? And see if we can name something. The reason why I'm saying let's try and do that before we add other functional groups or homologous series is so that we can understand how to name now. That when we now do other functions, then it will be easier, right? You're just translating from one to the next one. When naming, they call it IUPAC naming. I don't know what does this mean, but all I can say is that it's a universal way of naming organic molecular structure, right? Or naming organic molecules. So there are rules that I've constructed for you. It might change, right, with time, but for now, hopefully, I won't come back changing and say, nah, do this, don't do that. So the first thing when naming, you identify the longest chain in your molecule, right? Or in your structure. Then the second thing you can do is to number from one to the last carbon from that longest chain you've identified. Then number, should I say it number sequentially or number in order? I don't know how to structure this in English, but it's fine. Number the longest chain in sequential. Is it C or T? Sequential order. But this looks proper. Sequential order. And also do that in reverse motion. Or yeah, let me say do that in reverse order. Yes. Then I want you to identify something before you continue naming your structure, right? So I want you to identify these things. There's what we call order of precedence, right? So let me use this example. If we had, or we are to choose people to go and write a competition for men's in class, who will be the first person you choose? So that's what I want you to think of right now when I say order of precedence. So if you were to choose someone, yeah, in a normal format or in a normal way, you choose the best student, right, to go and write first, or to go and represent you to write the Mets Olympiad competition and all that. If he wasn't around, then you choose the second best. If the second best student wasn't around, then you choose the third one. If the third one wasn't around, then you reconsider the fourth one. So when I say order of precedence, I want you to write these things in order, right? Let's say here, for the sake of understanding, I even told you what's a homologous series, right? But in our case, our order of precedence will follow this format. It says homologous series, which is our best student, right? Then if the best student is not around, we go look for these two guys, alkene or alkyne. Then if these two guys, they're not around, we go and look for halogens. Then if this guy is not around, lastly, we look for the side chain. So this is the order of precedence that we are going to follow. right? For now, we only have these 3 rules, right? Then I'll introduce other things or little details further as we're doing the naming, right? So let's start with the simplest example. So let's say we have this carbon one. So our first rule says we identify the longest chain. So when identifying the longest chain, I want you to go and count the longest chain, counting the carbons, right? So if we were to count the carbons here, we'd see that we have 1, 2, 3, 4, right? You see, I didn't skip anything. So you should do that too. Then I've identified the longest chain is this one. Then what do I mean when I say number the longest chain in sequential order and do that in reverse order too? This is what I mean. So we'll start from left to right. So it's 1, 2, 3, 4. And also do it in reverse order. 1, 2, 3, 4. You see, I'm so specific in this numbering thing. You number the longest chain, not anything else, right? You number the longest chain. So in our case now, it won't be useful because there are no homologous series or other functional groups here other than alkane, which is a single bond. So it doesn't make any difference in this kind of an example. But I want you to follow this order every time, right? But for now, we can continue and try to name our thing, right? So I said our naming should follow this order. Position, side chain, then prefix, then position, then suffix. So in this case, we won't have any position in between the prefix because between the carbons, we don't necessarily have a double bond or a triple bond, or on a carbon, we don't have a different functional group, right? We haven't covered that, but you'll understand as time goes. Let's try and name, right? On the longest chain, do we have any other side chain which is not part of this longest chain? We can see there's nothing. We only have H atoms outside of this longest chain. So we'll forget about this part for now. Then let's go. Prefix. That's our language that we use, right? So if we have 4 carbons, we know it's bute. We'll say bute. For position, for now we don't have any position because there's no double bond or any other functional group in any atom, C atom. Then the suffix, because we're dealing with alkane, right? So it's a single bond. Then the suffix of alkane, it's ane. It's in the name. So we'd call this butane. Then let's do a different example. Let's say we have C, 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 and a side chain here. I hope I'm not complicating things, right? Sometimes you might think that you're trying to simplify something for someone, but you're actually making it worse. I hope you find this useful. And if you don't, it's okay. It's okay. Yeah, I hope you'll find someone who can explain it better. For this example, you identify the longest chain. That's our first rule, right? You identify the longest chain. One mistake I've seen people do is that they identify the longest chain because they think it's the longest chain, but they didn't actually check, right? So if we were to check here, we can check the longest chain by counting the C atoms. So the first one is 1, 2, 3, 4, 5. Someone might say that's the longest chain, right? Then another one might say, oh, actually, but this is the longest chain. 1, 2, 3, 4, 5. But it doesn't make any difference because in any order that you choose, you end up with 5 carbons, right? So let's circle the longest chain. And number sequentially, right? So it's going to be 1, 2, 3, 4, 5. So this is where this numbering system is so important, right? Because we also do it in reverse order. 1, 2, 3, 4, 5. I'll keep on repeating this because I want it to sink in your head that when you number sequentially on the longest chain, the chain that you've circled, then anything outside of that longest chain, you'll consider it as a side chain. Right. I also want you to consider halogen as side chains, but we'll cover that when we get there. That's not the proper way to do it, but for the sake of naming, do that. Then let's go and check where this side chain is positioned. So we can see in the forward order, it is positioned in the C atom number 4, but in reverse order, it is positioned in position 2, right? So the importance of numbering is that. So if you were to check the two orders, then you would have to choose the one with the smallest number, right, on the C atom. You'll have to choose the position with the smallest number. So between 2 and 4, the position that you are going to take is 2. So we disregard the forward numbering system and stick to the reverse numbering system. Hopefully it makes sense. Then let's try and name. So the structure that you are going to follow is this one. Position, side chain. So this means that the position of the side chain, this side chain is in which position, right? Then the prefix of the longest chain. Then let's do that. This side chain, it's in position what? Now we've identified that it's in position 2. Then we say 2 in our divider or our separator. Then if it's 1 carbon, we know it's math, but just because we're dealing with side chains, at the end, you just have to put the YL, right? So it's math side. Then we're done with the side chain. There's no any other side chain in this structure. Then let's see. How many carbons do we have? We have 5, right? 1, 2, 3, 4, 5. On the longest chain, that's very important. On the longest chain, we have 5 carbons. So 5 means pent. What kind of hydrocarbon do we have? It's an alkene. Then the suffix of an alkene is ane. So we have 2-methyl pentane. I hope it makes sense. Okay, let's proceed. Then lastly, let's see how this order of precedence work, right? For now, I'll just introduce another concept called halo alkane. It's on the name. So halo means halogens, which are your chlorine, bromine, fluorine, and your iodo. You have to double check. Then here it's your alkene. We've defined an alkene, right? Alkane, it's a single bond in between the C atoms. Then it's a combination of that. So what do I mean when I say combination of that? We have something like C, C, Cl. So it's a combination of halogens and alkane. So that's why we call it haloalkane. Let's take an example. So if we were to try to name this one, so you see we have, let me just write haloalkane. If we were to try to name that, we'd follow the order of precedence. I'm just taking a random example, right? For the sake of explanation. Let me put a side chain. Actually, let me add 1 so it can make proper sense. Then the first thing that we do is to identify the longest chain. Let's count. So it's 1, 2, 3, 4, 5. Someone might choose to say, okay, actually there's another one. 1, 2, 3, 4, 5. They both have 5 carbons, so I can choose any longest chain between the two, right? So I'll circle that. Hopefully you understand the numbering thing now. So it's 1, 2, 3, 4, 5. Then do it in reverse order. We number on the longest chain, right? I'll keep on repeating this because it's so important. 1, 2, 3, 4, 5. Yeah. Then everything outside of this longest chain, I said consider it your side chain, right? So now I'm introducing those little details that I was talking about, that when naming, because I can't make a list because it changes. I feel like it changes for me. I don't want to use a fixed order of doing things because it might not be consistent. Then let's try and name our thing, right? According to our naming convention, we first do the position of the side chain, the prefix, the position of the longest chain if there's any different hydrocarbon. But here we're still doing it with alkane, so we won't have this position. Then the suffix. So order is so important, right? So alphabetically, A comes before B, B comes before C, and all that. So when naming your side chains, try and follow that order of alphabet, right? So you'd see that this side chain starts with a C, right? Then this side chain is a methyl because we have one carbon. So you see M and C, what comes first? So C, right? So when naming, then we'll start with C. Then let's follow the order of precedence now. So the first thing that we did is to identify the longest chain. Then we numbered the longest chain in sequential order and in reverse order, right? Then we have to check the order of precedence. You see, we have a halogen and a side chain, which is methyl. Let's go and check if we can use this rule. Do you have a homologous series? Just say no for now because you don't see any, right? Do you have a double bond in between the carbons? No. Do we have triple bond in between the carbons? No. Do we have a halogen? Then yes, we have Cl. Then we stop there. We don't continue looking for the side chain. We stop there. And let's go and check. So we can see that looking at the halogen, let's look in terms of position on the carbon or its own position what. So we see in the forward order, it's in position 2. Then in the reverse order, it's in position 4. Then we take the position which is the smallest one between the two, between 2 and 4, and choose the smallest one, right? Then we'd consider the forward order and disregard the numbering system of the reverse order. Then in alphabetical order, C comes before M, right? So we'd name chlorine first. What's the position? Because I said everything else outside of the longest chain, we consider it as a side chain, right? So what's the position of Cl? It's in position 2. Then we call it chloro. Do you have any other side chain? Yes, it's a methyl. It's in what position? You see it's in position 4. So it's methyl. Then we can name the longest chain. How many carbons do you have? 5. That's our prefix. So it's pent. And we know that we are dealing with alkene. Then its suffix, it's A. I hope it does make sense, right? Then for now, I think we'll stop here and try and see if it does make sense when you try and do exercises for alkane.